In this video, we will learn about second law of motion. So the first law of motion suggests that to start motion in a stationary object or to change its state, an unbalanced external force must be applied. In other words, when an unbalanced external force acts on an object, its velocity changes, that is, the object gets an acceleration. But here, what the second law of motion states? So the second law of motion states that the rate of change of momentum of an object, okay, rate of change of momentum of an object, it is directly proportional to the applied force on it, and the change in momentum takes place in the direction of the applied force. Whatever the direction of force is there, the change of momentum is also in the direction of the force. Okay, so this is the expression. Now we will get the mathematical formulation of the second law of motion. So we will take an object M that is initially at rest when the time is 0. Okay, so it is moving with the velocity u. It is not at rest, but it is moving with the velocity u. A constant force F is applied on it so that it is uniformly accelerated. Now it is accelerated to a velocity v and time is equals to t seconds. So what is the initial momentum here? The initial momentum is m multiplied by u and final is m multiplied by v. The change in momentum, that is equals to p2 minus p1, which is mv minus u, as you can see here, right? So this is the change in momentum. Now the rate of change in momentum is delta p divided by delta t, which is mv minus u divided by t. Now, according to the Newton's law of motion, the force is, the change in momentum is directly proportional to the force, like this. That means F is directly proportional to m v minus u divided by t. That is, we will take equals to and we will take k as the constant. So F is equals to what? That is km, and this is v minus u divided by t. Now we know that force is equals to what? Ma, and acceleration is what? V minus u divided by t. So basically we will write m is equals to kma, and we know that force is what? Mass into acceleration. So if we put m equals to 1, a equals to 1, then we will get f equals to 1. So we will get k equals to 1 also. Okay, so from here we are getting f is equals to what? Ma. So this is the expression for the Newton's second law. Now, according to this mathematical formulation, we can say two things. First thing is we have F is equals to ma. So we will say F is directly proportional to the acceleration. Okay. And the second is F is directly proportional to the mass of the object on which that force is applied. So what is the directions here? So with the force to the acceleration, the graph is like this because mass is constant. To the force and mass, the acceleration is constant, so the graph is like this. Okay, so this is the graph for force to the acceleration and force to the mass. I hope this topic is clear to you. Thank you.